Hey, champs of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website www.examsnet.com. This site is a great place for you to practice your entrance exam question papers because here you will find so many entrance exam question papers along with the detailed PDF solutions. And you must download our app. The link is available in the description box for a better preparation of your exams. So today, students will be solving BITSAT 2023 Shift 1 paper. In this particular video, I'll be solving the physics portion of the physics part of the paper. So let's start with the paper. A very best of luck. Here we go with the question number 1. An object moves with the speed v1, v2, v3 along the segment AB, BC, and CD, respectively as shown in the figure, where AB is equal to BC and AD is equal to 3AB. So this AB. Okay, then the average speed of the object will be. You are given that AB is equal to AD is equal to 3 BC and this is equal to AB plus BC plus CD. This is equal to 3 AB. That this is also equal to AB. This gives me AB plus AB. That's 2AB plus CD is equal to 3AB. Or CD will be equal to AB. That means all of them are equal. Let's say this is X. Let's say AB is equal to BC is equal to CD is equal to X, right? Now, what you have to find out the average speed of the object. It is given by the total distance upon total time. Total distance divided by total time. What is the total distance? 3x. And the total time taken, okay, you are given the speed, right? So the speed for the time taken for the first AB segment, it will be here the time T1 is distance upon speed, time T2, distance upon speed V2. The time T3 taken will be distance upon the time speed V3. So this is given by, here the total time will be given by x upon V1, x upon V2, x upon V3. This will give me 3x upon x will be taken common 1 upon v1, 1 upon v2, 1 upon v3. This will cancel. And this, now I think you know the answer. On solving this will give me 1 upon v1 plus, this will be v2 into v3. And v1, v3 plus v1, v3. And v1 into v2 into v3, this will go in the numerator. So this is the answer to the question. And here you have option B as the correct answer. Hope you understood this. Next is question number 2. The effect of increase in temperature on the number of electrons in conduction band Ne and resistance of a semiconductor will be like both Ne and resistance decrease, both Ne and resistance increase. Any increase, resistance decreases, any decreases, and the resistance increases. See, when the temperature increases, more electron excite to conduction band, and therefore conductivity also increases. And with that, resistance decreases. That makes C option as the correct answer. Hope you got that. Let's move to the next question, number 3. A radioactive material is reduced to 1 by 8 of its original amount in 3 days. If 8 into 10 raised to power minus 3 kg of the material is left after 5 days, the initial amount of the material is, okay, radioactive material is reduced to 1 by 8 of its original 3 days. All right. So first of all, you have the value, the formula for this. Question number 3, a radioactive material is reduced to 1 by 8 of its original amount in 3 days. If 8 into 10 power minus 3 kg of the material is left after 5 days, the initial amount of the material is. So this is the radioactive decay formula is given by N is equal to N naught into 1 by 2 raised to power small n. So this is your amount of the radioactive material left after the decay. This is the original amount and not, this is n is amount of material left after decay and not is the original amount of material. And n is the half-lives. So according to this, now you are given in the question, the radioactive material is reduced to 1/8. According to question, n is equal to n naught by 8. So that means these two things are equal from 1 and 2. So let's say this is 1 and 2. From 1 and 2, you have n naught into 1 by 2 raised to power n is equal to n naught upon 8. That is 1 by 2 raised to power n is equal to 1 by 2 raised to power 3. This gives you n is equal to 3. So that means 3 half-lives in 3 days. That means 1 half-life in 1 day. And you are told that if this much of material is left, how much, if this much of the material is left after 5 days, what is the initial amount of material? Okay, so for 5 lives, it will take 5 days. 5 half-lives, it will take 5 days. So according to the formula, you have n is equal to n naught raised, sorry, n is equal to n naught into 1 by 2 raised to power n. Here, I am given that the material left is this much. So this is 8 into 10 power minus 3 is equal to n naught. I do not know. This is 1 by 2 raised to power 5. This will give me 8 into 10 power minus 3 is equal to n naught upon 2 raised to power 5. This is 8 into 10 power minus 3 into this. This will give you 256 gram. This is your initial amount of the substance, 256 grams. Option D is the correct answer. Hope you understood this. Next is question number 4. If 12.5 electron volt electron beam is used to bombard gaseous hydrogen at room temperature, the number of spectral lines emitted will be. Okay, see, if we assume electron in hydrogen atom takes, if we assume electron in hydrogen atom takes energy equal to 12.09 electron volt from the incoming radiation, the maximum excited state of the electron will be 3, n is equal to 3. So number of spectral lines will be given by this, that is equal to 3. Here we are assuming some part of the energy of, here we are assuming some part of energy let's write it here, 12.5 minus 12.09 electron volt, that is 0.41 electron volt get lost due to this collision. All right, so that makes this C option as the right answer. See, in the question it's given 12.5 electron volt. Question number 4, a 12.5 electron volt electron beam is used to bombard gaseous hydrogen at room temperature. The number of spectral lines emitted will be. Okay, see, if we assume electron in the hydrogen atom takes energy 12.09 electron volt, let's write it down. If we assume electron in hydrogen atom takes energy equal to 12.09 electron volt from the incoming radiation, the maximum excited state of electron will be 3. So number of spectral lines will be given by 3 into 3 minus 1 upon 2, that is 3. So 3 number of spectral lines. See here in the question, we are assuming that some part of the energy, we are assuming that some part of the energy 12.5 electron volt minus this much. So this much is the difference, 0.41 electron volt. This much got lost due to collision. Okay, so number of spectral lines, this is the answer 3. Option C is the correct answer. Hope you got that. Let's move to the next question. Question number 5. 1,000 droplets of water of surface tension 0.07 Newton per meter have same radius 1 mm each combined to form a single drop. In the process, the released surface energy is what? You have to take the value of pi is 22 by 7. So here 1,000 droplets, like 1,000 droplets combined to make a big drop of water. That means the volume of these combined droplets is equal to the volume of that big droplet. So you have volume of the initial droplet summation. Volume of the initial droplets is equal to the volume of the final droplets. And the volume is given by 4 pi r cube. So this is in the form of a sphere. So 4 pi r cubed, you have 4 pi r I, that is the initial radius of the droplets cube, is equal to 4 pi initial final radius of the droplet cube. 4 pi will cancel. You have r I cube is equal to rf cube. So here you are given the radius of each droplet is equal to 1 mm. So initial radius 1 mm, that is equal to 1 into 10 raised to power minus 3 meters. Right. Or number 5, 1,000 droplets of water of surface tension 0.07 Newton per meter having same radius 1 mm each combined to form a single drop. In the process, the released surface energy is. So here you have 1,000 droplets of water, right? And these droplets combine to make a big drop of water, right? So that means the summation of all the droplets, volume of all the droplets is equal to volume of the big drop. That is the final one. So Vi is equal to Vf, and the volume of a sphere is given by 4 pi r cube. That means 4 pi r initial cube into 1,000, because there are 1,000 droplets, is equal to 4 pi final volume, final radius cube. This will cancel. So you have final radius cube is equal to 1,000, or this is 10 power 3 into initial radius power 3, or the final radius is equal to 10 into Ri. That means the final radius is equal to 10 times the initial radius. So released energy, of course, it's released. So it will be initial surface energy minus final surface energy, or initial surface energy, that is equal to 1,000 into surface tension into pi r initial radius square minus t into 4 pi final radius square. Here you have 4 pi t, I'll take common, 1,000 ri square minus final radius square. Yeah. So, okay, you have a RF is 10 Ri. So let's fill in this 4 pi T 1000 Ri square minus 100 Ri square. I'm taking Ri square also common, 4 pi T into Ri square, that is equal to multiply by 900. Okay. Now T is given to you as 0.07 Newton per meter. So this is 4 into pi, that is 22 by 7, 0.07 into 900 into Ri, it is 1 mm, or I have to convert that into this radius is 1 mm. Let's do the conversion. Ri is 1 mm, or this is equal to, if I convert that into meters, this is 10 power minus 3 meters, and the square will give me 10 power minus 6 meters. So this is 10 power minus 6, and here you have 4 into 22 by 7, 7 upon 100 into 900 into 10 power minus 6. This will cancel, and ultimately you will have the answer 7.92 into 10 power minus 4 joules. This is the right answer to the question, and 7.92, this is option B. So this is the right answer to the question. Next is question number 6. The force between two small charged spheres having the radius this and this placed 20 centimeter apart in air is. You have the two charges, Q1 as this much coulomb, and Q2 is 2 into 10 raised to power minus 7 coulomb. And the distance between them, that is equal to 20 centimeter. Let's convert that into meters. So 20 into 10 power minus 2 meters. All right. And now the force between the two charged particles is given by K into Q1, Q2 divided by R square. Here, K is the constant. This is given by approximately 8.988 into 10 power 9 Newton meter square per coulomb square, which is approximately, I'll say, 9 into 10 raised to power 9 Newton meter square per coulomb square. Let's fill in all the values over here. So force between the two particles, two charged particles, will be given by, this is equal to 9 into 10 power 9 multiply 1 into 10 power minus 7 multiply 2 into 10 power minus 7 upon 20 into 10 power minus 2 square. So this is equal to 18 into 10 raised to power minus 18 and 14. Wait, no, this is 9. Okay, this is 14 minus 9, and this is 10 raised to power minus 5 upon 400 into 10 raised to power minus 4. So this will give me, on solving this whole thing, you will get 32 into, no, this is 4.5 into 10 raised to power minus 5 plus 4 minus 2. So this is 4.5 into 10 power minus 3 Newton. This is the answer to the question. And let's check with the options. You have option B as the correct answer. 4.5 into 10 raised to power minus 3 Newton. This is the right answer to the question. Next is question number 7. The work done in placing a charge of 8 into 10 raised to power minus 18 coulomb on a condenser of capacity 100 microfarad is. You have to find out the work done over here. It is given by the formula half Q square upon T. So this is half. The charge is 8 into 10 raised to power minus 18 square upon the capacity is 100 microfarad. Let's convert that into farad. So 100 into 10 power minus 6. This will give me, on solving, half into 8 into 8 into 10 power minus 36 plus 6, because I'm taking this up, divided by 100. Okay, so this is gonna cancel like 4, and you will have 32, because this is 32. Okay, I'll take this one also in the numerator, into 10 raised to power minus 32 joules. This is the right answer to the question, and you have option C as the correct answer. Hope you understood this. Next is question number 8. The resistance of a wire is 5 ohm. If the new resistance in ohm Sorry, I'll repeat the question. The resistance of a wire is 5 ohm. Its new resistance in ohm, if stretched to 5 times of its original length, will be. So here you are having, this is the wire. Okay, now in the final one, it's stretched to its 5 times. So if this is L, this is equal to 5L. The resistance is 5 ohm. Okay, this is equal to 5 ohm, and you know resistance is given by rho into length upon area. So also one thing, the volume will remain constant. So initial and final volume is same, that is volume remains constant. What is area? It's length into area. So L initial into initial area is equal to final length into final area. You know that final length is equal to 5 times initial length. So this becomes Li into Ai is equal to 5 Li into Af. Or this will give you Af is equal to initial area upon 5. That is, the final area becomes 1/5 of the initial area. Okay. Now, the final resistance, it will be given by rho into final length upon the final area. So, this is, I'm not touching the rho will remain like this. Final length is 5 times the initial length, and the final area is initial area divided by 5. So this will give me 25 into rho Li upon Ai. And rho Li upon Ai, this is initial for the initial ones, right? The resistance is given as 5 ohm. So this is equal to 5 from equation 1. This is equal to 125 ohm. This is the answer to the question. We have option C as the correct answer. Hope you understood that. Next is question number 9. Charged particle is moving in a uniform field given by this. If it has an acceleration of this much meter per second square, what is the value of alpha? Here you are given that it's a uniform magnetic field given by 2I 3j/t. Also, you are given that acceleration vector is alpha I minus 4j meter per second square. Now we know that force is given by Q V cross B. So what is your force? It's mass into acceleration. So mass into acceleration vector is equal to Q into V into B. And acceleration will be given by Q upon M V vector cross B vector. Therefore, A vector is perpendicular to B vector. If they are perpendicular to each other, that means their dot product is equal to 0. Let's do the dot product. So A is for alpha I minus 4j dot 2I plus 3j. This is equal to 0. 2 alpha minus 12 is equal to 0. This gives you alpha is equal to 6. And option B is the correct answer. Hope you got that. Next is question number 10. Proton and electron will have the same de Broglie's wavelength. And then when the ratio of their momentum is what? Okay, you have to assume that the mass of the nucleus is 1849 mass of the electron. All right. Let's see. Let's go to the question. Now, you are given that they are having the proton and electron, they are having the same de Broglie's wavelength. What is the de Broglie's wavelength formula? It is given by lambda is equal to h upon mv, and you are given that they are having the same wavelength. That means lambda of proton is equal to lambda of electron. Wavelength of electron and proton, they are same. So this will give me h, that is a Planck's constant, upon mp vp is equal to h upon me ve, which means both are mp into vp is equal to me into ve. This is what? This is a momentum. momentum of the proton is equal to momentum of the electron. That means their ratio is 1 is to 1. That makes option D to be the correct answer. Hope you understood that. Next is question number 11. A thermodynamic system is taken through cyclic process. The total work done in this process is, see, the work done will be area under the curve. Sorry, under the curve. Okay, so that means the work done will be equal to, this is half into 4 minus 2 multiply 400 minus 100. Okay, so area under the curve, this will be like, I'll be taking the area from here to here, this much, multiply by this, half of it. Question number 11, the thermodynamic system is taken through a cyclic process. The total work done in this process is, see, the work done will be equal to area under the curve. That means this area, the area of this simple area of the triangle. We have to find out the area triangle CDE. So work done will be equal to half into CE into DC. This is CE is 4 into 2 and DC is 400 minus 100. This is equal to, this will cancel, 300 joules. That makes C option as the correct answer. B option, sorry, as the right answer. Hope you got that. Next is question number 13. 12. In a reflecting telescope, a secondary mirror is used to reduce the problem of mechanical support. No. Remove spherical aberration. Make chromatic aberration 0 or move the eyepiece outside the telescope tube. That's right. Option D is correct, to redirect the light that enters the telescope to the eyepiece or camera. The primary mirror of the reflecting telescopes gathers all the light reflecting towards the secondary mirrors, reflecting towards the secondary mirrors, which then reflect the light towards the eyepiece, allowing the observer to see an object. It has an advantage of large focal length in a short telescope. That makes D as the correct choice. Next is question number 13. A magnetic moment of an electron revolving in an orbit around the nucleus with the orbital angular momentum is given by which of these options? So magnetic moment, first of all, it is given by I into area. And, I is equal to charge upon time. The current is equal to charge upon time. So this is equal to E upon 2 pi r into upon t. So your magnetic field, magnetic moment magnitude is equal to E upon 2 pi r upon t into area. It's given by 1 upon, not 1 upon, it will be pi r square. Okay, so pi r, this will cancel. This will be E into V into R upon 2. No, not the V I have. Studying the magnetic moment of an electron E revolving in an orbit around the nucleus with orbital angular momentum is given by which of these options? So you have the magnetic moment of the electron is given by the product of current into area. The vector product of magnetic moment is equal to I into A vector. So the magnitude will be given by, see, I is equal to charge upon time. So this is equal to E upon charge on an electron upon 2 pi r upon V. So let's fill in over here. This is E upon 2 pi r upon V multiplied by area is given by 2 pi r square. So this will cancel and you will have the magnitude of magnetic moment as half of EVR, or the magnitude of this is equal to MVR upon N upon 1 into E upon 2M. I'm multiplying the numerator and the denominator by M. So this magnitude, now what is this? This is your orbital angular momentum. L is equal to MVR. So this becomes equal to L into E upon 2M, or let's write it like this. Right, so the magnitude is equal to minus E L vector. Wait, not the magnitude. This magnetic momentum is equal to minus E L vector upon 2M. Now, why is that? Because M and L, why this negative sign is introduced? Because these two vectors are in opposite direction. So this negative is for that. Hope you understood this. So this is your first option. Option A. Hope you understood this. Next is question number 14. The ratio of intensities of the 2 points P and Q on the screen in Young's double slit experiment, where phase difference between two waves of same amplitude are pi by 3 and pi by 2, that is 60 and 90 degree respectively. So intensity at a point in Young's double slit experiment is equal to this. It's given by this. Now in the given question, you have I1 is equal to I0. The ratio of intensities of P and Q on this experiment, we have phase difference between two of them are respectively. So you have to find out. And in this question, I1 is equal to I2. Let's say this is equal to some I0. All right. So at the point P, IP will be equal to I0 plus 2 I0 into I0 into cos pi by 3. So this is equal to 2 I0 plus 2 I0 into cos pi by 3 is equal to, this is multiplied by cos 60. This is root 3 by 2. No, sorry, this is 1 by 2. That is for sine. This is multiplied by 1 by 2. So this gives you 3 I0 at the point P. Similarly, at the point Q, you will have at point Q, IQ will be equal to I0 plus I0 plus 2 root I0. Now in this case, it was cos pi by 2. This is equal to 0. So this is equal to 2 I0. IQ is equal to. You have to find out the ratio of the two intensities. So dividing both of them, you will have IP upon IQ is equal to 3 by 2. So this is equal to 3:2. That makes option C as the right answer. Hope you understood this. Next is question number 15. A bicycle tire is filled with air having the pressure of 270 kilopascal at 27 degrees Celsius. The approximate pressure of the air in the tire when the temperature increases to 36 degrees Celsius is. You know, for the ideal gas equation, you have PV is equal to nRT. Now at constant volume, because the volume will remain same at the constant volume, you will have P1. How is that? At constant volume, this is P1. V is equal to, wait for the first one. You have, I'll solve it over here. You have P1, V is equal to nRT1 and P2V is equal to nRT2. So from both of these, you have P1 upon P2 is equal to T1 upon T2. Okay, so this is, I'll write it over here, P1 upon T1 is equal to P2 upon T2. Hope you got this thing, right? I have just taken this thing over here. I have interchanged their positions. Now, for the first one, first temperature is 27 degrees Celsius, and the second one is 36 degrees Celsius. Let's change that into Kelvin. So you have 27 plus 273. Here is 36 plus 273. This is equal to 309 Kelvin, and this is equal to 300 Kelvin. So initial pressure is also given to you as 270 kilopascals. So P1, what is that? P1 upon T1 is equal to P2 upon T2. P1 is equal to 270 and kilopascals. I'll remain let it be kilopascals only. T2 is equal to 309 and this is equal to 300. This is equal to your P2. So this cancels and this is your 103. This is 10. This will give you, on solving, 278 kilopascals. Okay, so 278 is your C option. Hope you understood that. Let's move to the next question. Question number 16. A particle executes simple harmonic motion of amplitude A. The distance from the mean position when the kinetic energy becomes equal to the potential energy is. So first thing, I'll assume the distance from the mean position to be x. Distance, let the distance from the mean position is x. So in that case, what will be the kinetic energy? It is given by half mv square. So half m. It executes a simple harmonic motion. So I'll be taking the angular velocity half m omega square, a square minus x square. Okay, a is the amplitude and x is the distance from the mean position. So kinetic energy is given by this, and the potential energy is given by half m omega square x square. Okay, according to the question, both of these things are equal. You have kinetic energy is equal to potential energy. That makes half m omega square a square minus x square is equal to half m omega square x square. So these three things will cancel out. You will have a square minus x square is equal to x square, or 2x square is equal to a square. I had to find out x. It's given by root of a square upon 2, or this is equal to plus minus a upon root 2. This is option plus minus a upon root 2. This C is the correct option. Hope you understood. Next is question number 17. Electric field in a certain region is given by this vector. Then the SI unit of A and B are. See, electric field of a certain region, it is in the question A upon x square I cap B upon y cube j cap. So you have A upon x square as Newton per coulomb, right? And see, for this is in meters, x is in meters, x square will be in meters square. So if I only consider the A, it will be given by, see, only A will be left when I'll be multiplying it with x square. Okay, then only this and this will cancel. So in that case, I'll be multiplying the numerator with n square. So this will give me the vectors, the units of A will be equal to Newton meter square per coulomb. Same is for B upon y cube. Now this is again Newton per coulomb. To cancel out this y cube, see, y is equal to in meter, and the units of y are in meters, and y cube units will be meter cube. To cancel out this thing, I have to multiply it with y cube. Similarly, I have to multiply the units with m cube. This will give me the units of B are Newton meter square, meter cube per coulomb. This is option B. Hope you got that. Next is question number 18. At any instant, the velocity of the particle of 500 gram is given by this. If the force acting on the particle at 1 second is given by this, then what will be the value of x? So you have the mass of the particle as 500 gram. Which is 0.5 kg. Velocity V is equal to 2t I cap plus 3t square j cap meter per second. Yeah. Also, okay. Then what is acceleration? It is dv by dt, right? That means let's differentiate this one with respect to t. You will have 2I plus 6tj. Now, at this is t at time is equal to 1 second. This acceleration will be given by 2I plus 6j. Now, force acting on the particle is force F is equal to ma. Mass is this, A is 2I plus 6j. This will be equal to I plus 3j. This was your force. So, okay, what you have to find out? The value of x. Now, this is given to you in the question as this. I plus this is equivalent to I plus xj. So, clearly you have x as 3. All right, so this is the answer. X is equal to 3. Option A is correct. Next is question number 19. It says the particle of mass m moving with the velocity v collides with a stationary particle of mass 2m. After collision, they stick together and continue to move together with velocity what? So here you have, there is a particle of mass m which moves with the velocity as v, and it collides with a particle of mass 2m, which is stationary. That means its velocity is equal to 0. After collision, they stick together and continue to move together with velocity. Okay, this is what they stick together. So this is somewhat they are like this. This is the mass m and this is the mass 2m. Now they are moving with some velocity v dash. Over here, I'll apply the concept of conservation of linear momentum. So Pi will be equal to Pf, initial momentum is equal to the final momentum, and you know momentum is equal to mass into velocity. So you have m into v1 plus 2m into v2 is equal to m plus 2m into v dash. v2 is equal to 0, so you have m into v1, that is v is equal to 3m into v dash. Or you will have m and m will cancel. V dash is equal to V by 3, right? So let's check with the options. V dash is equal to V by 3. This is option C. So this is the right answer to the question. Hope you got that. Let's move to the next question number 20. Which of the following Maxwell equations is valid for the time varying conditions but not for the static conditions? See, for the time varying conditions, Maxwell equation given by question number 20, which of the following Maxwell's equations is valid for time varying conditions but not for the static conditions? See, for the static conditions, it is given by E vector dot dl vector. This is equal to 0. And for the time varying conditions, it is given by E dot dl. This is equal to minus d5 dB upon dt. This matches with option C. Hope you understood that. Next is question number 21. In a LC oscillator, if values of inductance and capacitance becomes twice and 8 times respectively, then the resonant frequency of oscillator becomes AX times its initial resonant frequency omega naught. What is the value of X over here? Okay, first think resonance frequency of LC oscillation circuit is given by omega is equal to 1 upon root of L dash C dash. Here in the question, you have L dash is equal to 2L because the inductance becomes twice and capacitance becomes 8 times. So C dash is equal to 8C. So this omega will be equal to 1 upon root of 2L into 8C. This is equal to 1 upon 4 root of LC. And omega naught, that is the original one, is equal to this. So from these two equations, you have omega is equal to 1 by 4 of omega naught. So in the question, it said that the resonant frequency of the oscillator becomes x times. So according to the question, you have omega is equal to x times omega naught. That means x is equal to omega. Sorry, x is equal to 1 by 4. All right. So here is your answer. Option A is the correct answer. Hope you got that. Next is question number 22. Conducting loop of radius 10 upon 2 pi centimeters is placed perpendicular to a uniform magnetic field of 0.5 t. The magnetic field is decreased to 0 in 0.5 seconds at the steady rate. The induced EMF in the circular loop at 0.25 seconds is. Okay. So first of all, let's understand the conducting loop is having the radius 10 upon root of pi centimeters. This is equal to 10 upon root pi into 10 power minus 2 meters. Also, the uniform magnetic field is given by this. The magnetic field is decreased to 0 in 0.5 seconds at a steady rate. So the induced EMF at 0.5 seconds is given by change in magnetic flux. This is in the opposite direction. EMF and the magnetic flux, they are in the opposite direction. So minus will be introduced over here. This is equal to minus A into dB upon dt. So here you have theta as 0 degrees. So cos 0 degree is equal to 1. Area is pi r square. So this is equal to minus pi r square into dB. Now it has been changed. This is the uniform magnetic field and it is decreased to 0. So this is the final and this is the original one, initial one. So this is 0 minus 0.5 and the time taken is 0.5 seconds. Hope you understood this. So now for finally, this is equal to minus pi into 100 into 10 power minus 4 upon pi into minus 1. So this thing will cancel and minus will cancel. Ultimately, you will have 10 power minus 2 volt. Okay. Or this is 10 millivolt. Now, in the question, it is said what it's a uniform magnetic field. So that means dB upon dt is equal to 0 because the magnetic field is uniform. dB upon dt is equal to constant, not 0. It is constant. So induced EMF will not change with time. Therefore, how much in EMF is introduced at the time 0.5 seconds is equal to the induced EMF at the time 0.25 seconds also. And that was equal to 10 MV. So this is the right answer, 10 MV. Option B is the correct answer. Hope you understood this. Let's move to the next question, number 23 now. Disk is rolling without slipping on the surface. The radius of the disk is r at t is equal to 0. The topmost point on the disk is A, as shown in the figure. When the disk completes half of its rotation, the displacement of A from its initial position is. Okay. So from the figure, you have this is the initial position of A. After it has rolled over some distance, where will A go? It has said when the disk completes half the rotation. So now this point will come over here when it has completed half the rotation. Let's say this is A dash. Now this is diameter 2r. And how much is this? Because the disk has completed half the rotation. So let's say this is a point B. So A dash B will be half of 2 pi r, which is pi r only. So A dash B is equal to pi r. AB is equal to 2r. What I need to find out is A dash easy by applying the Pythagoras theorem. A dash is equal to root of 2r square plus pi r square. So you have r square outside. This is 4 plus pi square. This is first option. This is the right answer to the question. Hope you understood this. Next is question number 24. Two planets A and B of radii r and 1.5 r have densities rho and rho by 2 respectively. The ratio of acceleration due to gravity at the surface of B to A is. First thing, acceleration due to gravity is given by g into m upon r square. G is your universal gravitational constant. Constant mass of Earth and this is radius of Earth, right? Now, okay, I have to introduce the density somehow. You know, density, that is rho, is equal to mass upon volume. This is, let's do on the separate note. You know, density is equal to mass upon volume, or mass is equal to density into volume. So let's write the same thing. You have G as equal to, also one thing, volume is equal to 4 by 3 pi r cube. So from here you have G is equal to, small g is equal to capital G into mass is equal to rho into V upon r square. So this is G into rho. This is for the planet A. Rho into volume is 4 by 3 pi r cube divided by r square. So this will cancel and GA is equal to 4 by 3 into pi into G rho into r. Okay. Now similarly, let's go for GB. This is equal to G into, now the rho by 2 is there. I will write it like this. Rho by 2 into 4 by 3 pi r cube multiply 1 by r square. This and this will cancel. This will be 2. This is there. So you have a 2 upon 3 into pi into g into rho into r. This is GB. Let's find out their ratio. So GA upon GB. This is what I need to find out, right? Their ratios. So GA upon GB is equal to, it will be 2:1. There is a mistake. This radius was equal to 1.5 r. So I have to do some change over here. This is 1.5 r. Okay. So let's do this step again. GA upon GB is equal to 4 by 3 pi GB into r divided by 2 by 3 pi G rho, not B, sorry, this is rho, into 1.5 r. So these all cancellations will be there. So you have GA upon GB is equal to 2 into 10 upon 15, or this is 3 and this is 2, this is 4:3. Or what do you have to find out? Density of B is 2A. So you had to find out GB upon GA. This is equal to 3:4. This is the answer. Let's check with the options. 3:4. This is option C. Hope you understood that. Let's move to the next question. Question number 25, a 100-meter long wire having cross-sectional area 6.25 into 10 power minus 4 meters square. Young modulus as this is subjected to a load of 250 newtons. Then the elongation in the wire will be. So let's write down the things which are given. The length of the wire is 100 meters and the cross-sectional area is 6.25 into 10 power minus 4 meters square. Young's modulus is 10 power 10 Newton per meter square, and you have given the load, that is, I will take it as a force only, 250 newtons, and you have to find out elongation in the wire. So basically you have to find the change in length, right? And this change in length is given by force into length upon Young's modulus into area. So you know everything. Let's fill in the values. Just the force is 250 newtons, and the length is 100. Young's modulus 10 power 10. Area is this. So on solving this whole thing, you will get 40 into 10 power minus 4 meters, or the answer to this question is 4 into 10 power minus 5. 4 into 10 power minus 3, not minus 5 meters. So that makes option D to be the correct answer. Hope you got that. Next is question number 26. The ratio of the speed of sound in hydrogen gas to the speed of sound in oxygen gas at the same temperature is. All right. You are having two gases, hydrogen and oxygen. What is the molecular mass of hydrogen? This is 2 into 1, that is 2. And the molecular mass of oxygen is 32. Now, speed of sound is given by the root of this expression, where this is adiabatic index, this is gas constant, T stands for absolute temperature, and M molecular mass. Right, so that means the speed of the sound is let's say this is equal to V, speed of the sound V is equal to, so this is inversely proportional to the root of M. So that means the speed of sound in hydrogen upon the speed of sound in oxygen is given by the root of molecular mass of oxygen divided by the molecular mass of hydrogen. This is 32 upon 2, or this is equal to 4:1. Right, so you have first option as the correct answer. Hope you got that. Next is question number 27. The free space inside the current carrying toroid is filled with the material of susceptibility 2 into 10 power minus 2. The percentage increase in the value of a magnetic field inside the toroid will be. So you are given susceptibility Question number 27, the free space inside a current carrying toroid is filled with the material of susceptibility 2 into 10 power minus 2. The percentage increase in the value of magnetic field inside the toroid will be. So in the question you are given susceptibility is 2 into 10 power minus 2. So I'll be using mu r is equal to 1 plus this, so it is 1.02. Now, final magnetic field is mu naught BR, B naught. This is your initial magnetic field. So, percentage increase in magnetic field is given by final minus initial magnetic field divided by the initial multiply 100. And the final one is given by this. Let's write minus B naught upon B naught into 100. So let's divide the numerator and the denominator by B naught. You will have mu naught minus 1 into 100. And this is equal to, this is not mu naught, this is mu r. So mu r is equal to 1.02. Let's write, this is 1.02 minus 1 into 100. This will give you 2%. So you have option A as the correct answer. Hope you understood that. Let's move to the next question. Average or the ratio of average electric energy density and the total average energy density of an electromagnetic wave is. See, magnetic and electric fields can also store energy. In case of electric field or capacitor, in case of electric field or capacitor, the energy density formula is given by U is equal to half. This is energy density formula. So U for U is given by half E naught into half into E naught E square, where this is permittivity of free space and this represents your electric field. Also, the energy density formula. This was for the case of electric field, energy density formula for magnetic field or inductor. This is given by U is equal to, let's say this is for the magnetic field, so I'm representing it with UV. This is UE. This is equal to half upon 2 mu naught into B square, where this is your magnetic field and mu naught is permeability of free space. All right. Now, regarding the electromagnetic waves, both magnetic and the electric field, they are equal. They are equally involved in contributing to the energy density. So, energy density, total energy density, this will be the sum of electrical plus magnetic energy density. All right. Now, let's get back. What we have to find out the ratio of average electric density, energy density to the total. So, what do you require? Required ratio is UE upon the total energy. This is equal to UE plus magnetic plus electric energy density. And we already have seen that UB is equal to UE. That means half was mu naught into B square is equal to half E naught E square. Okay, so let's get over here. This is equal to UE. I will write it as UE plus UE. This is equal to 1 UE upon 2 electric energy density. This is equal to 1 by 2. So you have B option is the right answer to the question. Hope you got that. Next is question number 29. In a Young's double slit experiment, the intensity is at 2 points for the path difference lambda by 4 and lambda by 3, lambda being the wavelength of the light used are I1 and I2 respectively. If I0 denotes intensity produced by each of the following, by each one of the individual slits, then what is the value of I1 plus I2 divided by I0? Okay. Resultant intensity in Young's double slit experiment is given by I is equal to 4I naught cos change in magnetic flux upon 2. Now, for the path difference lambda by 4, the phase difference is given by 2 pi upon lambda into lambda by 4. This gives you pi by 2. Let's fill in for this equation. So you have I1 is equal to 4 I naught cos pi by 2 upon 2. This is equal to 4 I naught cos pi by 4 or What is cos pi by 4? This is equal to 1 by 2. Yeah. So this comes out to be 2I naught. Similarly, for phase difference of lambda by 3, you have I2 is equal to 4I naught. This was question number 29. In a Young's double slit experiment, the intensity is at 2 points for the path difference lambda by 4 and lambda by 3, where lambda being the wavelength of the light used are I1 and I2 respectively. If I0 denotes the intensity produced by each one of the individual slits, then what is the value for I1 plus I2 divided by I0? All right, so resultant intensity in Young's double slit experiment is given by I is equal to 4I naught cos square delta phi upon 2. Now, for the path difference of lambda by 4, for path difference of lambda by 4, the phase difference is given by, this will be equal to 2 pi upon lambda into lambda by 4, which is equal to pi by 2. So now let's fill in this value over here. So I1 will be equal to 4I naught cos square pi by 2 upon 2, which is equal to 4I naught cos inverse pi by 4. This is 4I naught cos inverse, cos square pi by 4. So this is equal to 1 by root 2 whole square. This will give you 2I naught. Okay. Similarly, for path difference of lambda by 3, phase difference will be given by 2 pi upon lambda into lambda upon 3. So this will be 2 pi upon 3. So I2 in this case, again, I'm using this equation. I2 will be equal to 4I naught cos square 2 pi by 3 divided by 2, which is equal to 4I naught cos square pi by 3. This gives you 4I naught cos square pi by 3. This is root 3 by 2 square. So this is equal to 3I naught. Now required value was I1 plus I2 upon I naught. This is equal to 2I naught, this is equal to 3I naught, and this is this. There's a change, sorry, cos of 60 degree is, that is pi by 3, is equal to 1 by 2, not root 3 by 2. So this is supposed to be 1 by 2, and here you will have I naught only, right? So this is equal to 3I naught upon I naught, or 3. So the answer to the question is option A. Hope you understood that. Let's move to the next question. Question number 30, the energy levels of an atom are shown in this figure. Which one of the following transitions will result in the emission of a photon of wavelength 124.1 nanometers? You're given the value of H as this. So first thing, the wavelength is given by Hc upon the change in energy. So for the first A, delta EA, this is given by this 2.2 electron volt, and let's write it here. For EB, this is equal to 5.2 electron volt, and EC, this is, see, it is moving from here to here, so 5.2 minus 2.2, this will be 3 electron volt. And ED, change in ED, this is 10 electron volt. So let's consider their respective wavelengths. lambda A. Over here, this will be given by, I'm filling in the values from here. H is taken as this, 6.62 into 10 power minus 34. C is the speed of sound, so 3 into 10 raised to power 8. And change in energy is 2.2, and this will be multiplied by the charge on an electron, because this is in EV, so charge on an electron is 1.6 into 10 raised to power minus 19. All right. This is the speed of light, not speed of sound. So this on solving will give you approximately, this will be 564 nanometers. And let's calculate the wavelength for the B. This will be the same, 6.62 into 10 power minus 34 into C's 3 into 10 power 8 divided by, this is 5.2 into the charge on one electron. This is gonna give you 238.65 nanometers. Similarly, the C wavelength, this is 6.62 into 10 power minus 34 into 3 into 10 power 8 divided by 3 into 1.6 into 10 raised to power minus 19. That's gonna give you 413.66 nanometers. Then the last, D wavelength, 6.62 into 10 power minus 34 into 3 into 10 power 8 divided by 10 into 1.6 into 10 raised to power minus 19. This is equal to 124.1 nanometers. So this matches with the given wavelength. That means D. This is the right option. So students, with that, we have completed all the 30 questions of your physics section for this paper. And don't forget to visit our website, www.examsnet.com. You also must download our app. The link is available in the description box for a better preparation of your exams. So very best of luck. Keep shining, keep rising high. That's all for this paper. Bye. That's of Examsnet. Welcome to the question series of Examsnet. Students, you must have explored our website, www.examsnet.com. This site is a great place for you to practice your entrance exam question papers, because here you will find so many papers along with the detailed PDF solutions. Also, you must download our app. The link is available in the description box for the better preparation of your exams. So students, here we go with the first question for the paper of BITSAT 2023 Shift 1. I'll be solving the chemistry questions in this particular video. So a very best of luck. We'll start with the first question. 30 questions of chemistry will be there in this video. A very best of luck. Here we go. First question. It says Frankel and Schottky defects are nucleus defects? No. Non-crystal defects. They are crystal defects. These are crystal defects. It arises due to dislodgement of cation or anion from their places in the crystal lattice, right? So you have C option as the correct answer. Hope you got that. Next is question number 32. The Bohr's orbit radius for the hydrogen atom where n is equal to 1 is approximately 0.530 angstrom. The radius of the first excited state n is equal to 2 orbit is. So you're having, let's write down first thing, radius of hydrogen atom 0.530 and number of excited state is 2. What is the atomic number of H, hydrogen atom? It's 1. So we know Bohr's radius is given by R is equal to n squared upon Z into radius of atom. So this is 2 squared upon 1 into 0.530, which will give you 2.12 angstrom. So you have D option as the right answer. Hope you understood that. Next is question number 33. The probability density plots of 1s and 2s orbitals are given here. The density of the dots in the region represents the probability density of finding electrons in that region. On the basis of the above diagram, which of the following statements is correct? Okay. First, 1s and 2s orbitals are spherical in shape. No, the probability of finding the electron in the is maximum near the nucleus. No, that's not true. The probability of finding the electron at the given distance is equal in all the directions. The probability density of electrons for 2s orbital decreases uniformly as the distance from the nucleus increases. That is absolutely right. See, the probability density of the electrons in the 2s orbital first increases and then it decreases, and after that it increases again. After that it increases again as the distance increases from the nucleus. So this is the pattern that makes D option as the correct answer. Hope you understood that. Next is question number 34. Element with the electronic configuration. This belongs to the following group of the periodic table. Okay, to answer the question, I need to look at the valence shell. Valence shell is 5s2 5p3. So this is having 5 electrons. It belongs to the, therefore, it belongs to 15th group. That makes option B as the correct answer. Hope you understood that. Next is question number 35. Which of the following pairs will form the most stable ionic bond? Na and Cl, magnesium and fluoride, lithium and fluoride, sodium and fluorine. So see, among all of them, I think option B, magnesium and fluorine, they are the correct answer. See this, when I'm forming the ionic bonds, the stability of the ionic bond depends upon the lattice energy. Stability of ionic bond depends upon the lattice energy, which is expected to be more between magnesium and fluorine due to +2 charge on the magnesium atom. So you have B option as the right answer. Next is question number 36. How much ethyl alcohol must be added to 1 liter of water so that the solution will freeze at 14 degrees Celsius? Okay, so you have care for the water as this. All right. So first thing, how much ethyl alcohol must be added to 1 liter of water so that the solution will freeze at 14 degrees Celsius. Normally the water freezes at 0 degrees Celsius, and now you are asked the water should freeze at 14 degrees Celsius. So the change in temperature is 14. Right. Also, delta TF is given by KF into M. So KF for water is 1.86. This is equal to 14, and M is given by how much ethyl alcohol is needed. Let's say that's N2. So this is multiplied by 1000 divided by 1000. This will cancel. N2 will be equal to 14 upon 1.86. So this is 7.5 moles. So 7.5 moles of ethyl alcohol is needed for this purpose. You have option A for the answer. Next is question number 37. The conductivity of weak acid HA of concentration this much is given by this much. If the molar conductivity for the infinite dilution for HA is this, the ionization constant Ka for HA is equal to how much? All right. So molar conductivity is given by 1000 into specific conductivity upon this is M, the molar mass. So this is equal to 1000 into 2 power into 2 into 10 power minus 5 divided by 0.001. This will give you 20 centimeter square per mole. All right. And you're given the molar conductivity for the infinite dilution as well. So alpha is given by this. This is equal to 20 upon 190. So this is 2 upon 19. So HA is now dissociated to form H plus A negative. So if I'm having initially the 0.01 moles of it, and after the formation of alpha, this will be 0.001 minus alpha. And here will be 0.001 alpha formation. Right. Now, what you have to find out is Ka. That is given by 0.001 into alpha square upon 1 minus alpha. This is equal to 0.001 into 2 by 19 square divided by 1 minus 2 by 19. So this will give you 0.004 upon 19 square divided by, this will be 17 upon 19. On solving this whole thing, you will get the answer as 12.03 into 10 power minus 6. So 12.03 into 10 power minus 6, this is okay, 10 power minus 6 is here, so here should be 12. That makes option C as the correct answer. Hope you understood that. Next is question number 38. Plots showing the variation of the rate constant K with the temperature T are given below. The plot that follows Arrhenius equation is. See, as per this equation, you have K as A E bar minus EA upon RT. The rate constant increases exponentially with temperature, and the exponential according to this equation. So in which of these graphs it's increasing exponentially? It is option A. This is not increasing exponentially. This is decreasing exponentially. This is also not exponentially. So you have option A as the correct answer. Hope you understood this. Let's move to the next question now. Which of the following method is used for coagulation of sole? By mixing two oppositely charged soles by electrophoresis, addition of electrolytes. See, the process of settling of colloidal particles is called coagulation of sole. The methods for separation of, the method of coagulation of sole, the two methods are like by mixing oppositely charged soles, electrophoresis, addition of electrolytes. All of these are correct. That makes the option to be the correct answer. Hope you got that. Next is question number 40. The reaction that does not take place in the blast furnace between 900 Kelvin to 1500 Kelvin temperature range during the extraction of iron is. Okay, let's list down some of the reactions that take place at this much of temperature. So at higher temperature range, in the blast furnace, some of the reactions that take place are carbon plus oxygen. It gives you carbon monoxide. And iron oxide plus carbon monoxide gives you iron plus carbon dioxide. Calcium oxide, silicon dioxide gives you calcium silicate. Here you have the slag formation. And this reaction, if I talk about Fe2O3 plus carbon monoxide gives you 2FeO plus carbon monoxide. This takes place at 500 to 800 Kelvin. So this is the right answer to the question, because this does not take place at 900 to 1500 Kelvin. Option A is the correct answer. Hope you understood that. Next is question number 41. Kinetic theory of gas proves only Boyle's law, only Charles' law, only Avogadro's. No, it proves all of these. Kinetic theory of gases proves Boyle's law as well as Charles' law as well as Avogadro's law. You have option D as the answer. Next. Number 42, enthalpies of the formation of C2H4 gas, carbon dioxide, water at 25 degrees Celsius, 1 atmosphere are this, respectively, kg per mole, respectively. Then the change in enthalpy of the combustion of C2H4 is equal to. All right. So you have enthalpies of formation of C2H4. This is 52 kilojoules per mole for carbon dioxide, and for water, this is 394. This is 286 kilojoules respectively. So let's write down the reaction. You have C2H4 plus oxygen. This gives you carbon dioxide and water. Right, it's balanced. So here you have 2. Here you have, if you're having 2, the oxygen becomes, this will be 2 and C2H4. I think it's balanced. No, this will be 3. Fine. So now the change in enthalpy is given by delta H is equal to change in enthalpy of the products minus reactants. And for the products, it is equal to 2 into this is 394. And wait, for carbon dioxide, it should be minus 394. Okay. And for the products, this is this plus 2 into minus 286. And for the reactants, it's this much. So total of minus 41412 kilojoule per mole. This is the change in enthalpy, and this is your B option. Hope you understood this. Next is question number 43. The photochemical smog does not generally contain nitrogen dioxide, sulfur dioxide, nitrogen dioxide, or HCHO. See, the photochemical smog contains nitrogen dioxide, ozone, PAN, that is peroxyacetyl nitrate, and compounds containing CHO group. It does not generally contain question number 43. The photochemical smog does not contain NO, SO2, NO2, or HCHO. See, the photochemical smog, this contains nitrogen dioxide, oxygen, PAN, which is peroxyacetyl nitrate, and compounds containing CHO group. So you have B option, that is sulfur dioxide. This is not in the photochemical smog. Hope you understood that. Let's move to the next question, number 44. The geometrical isomerism is not shown by which of these following? See, the condition for geometrical isomerism is given by this is C, A, B. Here is double bond C, here is A and B, or this is like this, double bond C, ED. All right. So if I look at all the options, this one, CH2, CCl, CH3, this does not follow this above mentioned condition. That makes C option as the right answer. Hope you got that. Next is 45. For the separation of two immiscible liquids, which method is used? Two immiscible liquids. That means that can't be fused with each other, which it does not mix together with each other. Chromatography, no, it is not used for immiscible liquids. Fractionating column, no. A fractional distillation, no. Separating funnel, definitely it is used when two liquids are immiscible. So fractional distillation, that is one liquid will remain on the above and another will go down. So you have the option. That was a pretty easy one. Next is question number 46. What is X in the following reaction? Aluminium solid, sodium hydroxide aqueous, water liquid gives you X plus hydrogen. So basically what you have to do is complete the reaction. Aluminium reacts with sodium hydroxide and water to gives you NaAlOH4 in the aqueous plus hydrogen gas. Let's do the balancing. Here you have NaOH, H2. This will be 2, 2, 6. This is in the liquid form. This is aqueous and solid form. Here the sodium is 2 and the hydrogen molecules 3. Okay, so right, what you have to find out is X. X is nothing but, okay, this is given in the ionization form. So this is Na plus and this is negative. That makes option B as the right answer. Hope you understood this. Next is question number 47. Which of the following will precipitate first when aqueous solution containing sulfate ions are added? Magnesium, calcium, Sr2 plus or Ba2 plus. See, down the group, solubility of sulfate decreases. But thus you have barium 2 plus ions will precipitate very easily. Okay, so this is the right answer. Hope you understood. Next is 48. Ionic hydrides react with water to give. See, let's see any hydride, ionic, that is lithium is forming an ionic bond easily. So ionic hydrides, like say lithium hydride on reaction with water, it will give you hydroxide of it plus hydrogen. So ionic hydrides give the basic solution when treated with water. Okay, so you have C option as the right answer. Next is 49 question. The drug used in antidepressant is luminol, tofranil, mescaline, or sulfadazine. The right answer to the question option B. Tofranil is used in the treatment of antidepressant and option B is the right answer. Next is question number 50. Melamine plastic crockery is a copolymer of HCHO and melamine, HCHO and ethylene, melamine and ethylene, or none of the above. See, the melamine plastic crockery is a copolymer of melamine and HCHO. Option A. Hope you got that. Let's move to the next question. Question number 50. Melamine plastic crockery is a copolymer of. The answer to the question is formaldehyde and melamine, option A. Melamine resin is a thermosetting polymer made up of melamine and formaldehyde. It's given by this. You have N, 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 and over here, this is a double bond with NH2. Here is N, and double bond here is NH2. And then you have a double bond and this moves with NH2 again and a single bond over here. This is your melamine. Now this, when combines with the formaldehyde HCHO, this gives you melamine resin in the form N. There is NH again forming, and you have N over here, double bond in H, again a bond, and here is single N, then followed by double. So here you have This combines with NH like this. This is your melamine resin. So this is option A, the right answer to the question. Hope you understood this. Let's move to the next question, number 51. The helical structure of a protein is stabilized by which of these options? See, the alpha helix structure is formed when the chain of alpha amino acids coils as a right-handed screw, which is called alpha helix. Because of the formation of hydrogen, this is because of the formation of the hydrogen bonds between the amide groups and same peptide chain. That is your NH group in one unit is linked to carbonyl group, carbonyl oxygen of the third unit of hydrogen bonding. This hydrogen bonding between different units is responsible for holding the helix in its position. So you have option B, hydrogen bonds, as the right answer. Hope you understood this. Next is question number 52. Which of the following factors affect the basic strength of amine? Inductive, steric hindrance, solvation effect, solubility in organic solvents. This is wrong. The first three are correct. That makes option B as the correct answer. In the question, inductive effect, steric hindrance, inductive effect, steric hindrance, and solvation effect, all of these affect the basic strength of amines. So based on these combined effect of all these, the if I write down in the decreasing basic strength of amines, this is decreasing basic strength of amines is given by, first of all, you have the secondary amines, then tertiary. They are having the highest strength, then the tertiary, and the primary ones have the least. This is the order we observe in the aqueous solution. Secondary amines are the strongest ones. If I talk about the inductive effect in the nitrogen basicity, this effect makes the electron density on alkyl amines, nitrogen, greater than nitrogen of ammonia. The small amount of extra negative charge built up on the nitrogen atom makes a lone pair even more attractive towards the hydrogen ions. And solvation effect. Before talking about that, let's talk about the steric hindrance. Due to the combined effect of the plus I on alkyl group, the steric hindrance caused by the alkyl groups and the solvation of amines through hydrogen bonding. Solvation is the formation of protonated amines when they are dissolved in water. As the number of hydrogen atom on nitrogen increases, the possibility of hydrogen bonding also increases, providing greater strength to the amines. So you have B option as the correct answer. Hope you understood that. Let's move to the next question, number 53 now. You have to find out B in the given reaction. So what is this B? So in that case, you just have to complete the reaction. This is a benzene ring. When CH, it reacted with CH3X in the presence of aluminium chloride. This is Friedel Crafts alkylation. So this gives you methyl group attaches over here. This is your A. Now again, in the presence of hydronium ions and chromium oxide in CH3CO2O, this gives you this product. So this is B, and this is your benzaldehyde. This is B. So you have option B as the correct answer. Hope you understood. Next is question 54. Which method is useful for synthesis of ether out of these? See, in the synthesis of ether at 443 Kelvin, compound in the D option will produce. Question number 54, which method is useful for synthesis of ether? If I look at the options, the first option, in this one, an alkene will be produced as tertiary alide and the strong base favors elimination. In the reaction B, it is not possible at room temperature, like at 30 degrees Celsius at room temperature, it's not possible due to the resonance of CCl bonds. They have the partial double bond character, which is very difficult to break. And the third one, before discussing the third one, I'd like to talk about the fourth one. This is the reaction at 443 compound. In this, at this temperature, this D reaction, D option will produce propene. So if I look at the third option in this, the complete reaction, let's write it down over here. So I'm writing this is the complete reaction. Let's write it over here. So you have CH3O Na, yes, plus CH3 CH2O, it's SO2, and then a benzene ring and CH3 over here. All right, so this is negative and this is positive. It will link over here and this will break up. All right, so this is your tosyl group, this one. Okay, so this will yield you O, this tosyl group, plus CH3, CH3O, CH2, CH3. So this is the one, this is used in the synthesis of ether. Option C is the correct answer. Hope you got that. Let's move to the next question. Question number 5. Among the given halides, which one will give same product in both SN1 and SN2 reactions? The correct answer to the question is 3 and 4. These two. See, in these, these are achiral molecules, and their structures do not permit rearrangement. Hence, they give the same product with SN1 and SN2 reactions. However, the rest two, the first and the second one, they are chiral molecules, and hence they give anechotomerically pure products. Question number 55, among the given halides, which one will give the same product in both SN1 and SN2 reactions? The correct answer is 3 and 4. That gives option C. The 3 and 4, they are achiral molecules, and their structures do not permit rearrangement. Structures do not permit rearrangement. Therefore, option C is the correct answer. Whereas if I look at the first and the second option, they are chiral molecules and they give different products. So you have option C as the correct answer to the question. Next is question number 56. Among the given ligands, NH3, these all, the correct order of the increasing field strength is given by. Okay. The ligands can be arranged in a series based on the order of increased field strength as given below. For the weak field strength, you have iodide, bromide, sulfide, SCN, chloride, and 3 minus. This is N3 minus, fluoride, urea, hydroxyl, and this is again less than oxalate. And the strong field ligands, strong field ligands, they are given by oxide, water, NCS, EDTA, PY, NH3, EN, which is equal to SO3, less than SO3 negative, less than by pi, when NO2, CH3, C6H5 negative, Cn and CO. Such a series is termed as spectrochemical series. Spectrochemical series. It's an experimentally determined series based on the absorption of light by complexes with different ligands. So you have this as the right answer, option A. Hope you understood that. Let's move to the next question then. Question number 57. SS bond is not present in which of these options? If I look at the D option, this is given by S double bond O. O. Here is O negative, then O, O, S, O, O, O negative. So there is no S bond present in this. That makes option D as the correct answer. Hope you understood this. Next is question number 58. In the laboratory, manganese 2 salt is oxidized to permanganate ion in aqueous solution by which of the following? In the laboratory, manganese 2 iron salt is oxidized to permanganate ion in aqueous solution with peroxodisulfate. Let's do the reaction. So you have manganese salt that will give you and manganese ion Mn2 plus with peroxosulfate. This is S2O8 2 negative with water. It will give you MnO4 minus plus sulfate plus hydrogen ions. So let's do the balancing. Here will be 2, 5, 8. Here will be 2, then 10 and 16 over here. So this is peroxy disulfate. So we have C option as the correct answer. Hope you got that. Next is question number 59. Which are the following molecular hydrides act as Lewis acid? In this one, boron is electron deficient and doesn't have a complete octet. Therefore, it is acting as a Lewis acid. Because electron deficient molecules, they behave as a Lewis acid, and only in this is diboron. In this boron is electron deficient. That makes this as the correct answer, option C. Next is the last question for the paper, question number 60. Electrode potential data are given below. This is the data. Based on the data, the reducing power of Fe2 plus aluminum Br minus will increase in the order. So these are your three reduction reactions. So over here, the electrode potential for the reduction, and these are the three ions or molecule at this element Al, Br minus. For ferrous, this is 0.77 volt, and these are the reduction electrode potentials. And for the oxidation, it will be the opposite of it. This will be minus 0.77. This will be plus 1.66. This will be minus 1.08. Now you have to find out the reducing power of this will increase in which order. So the reducing power will be given by Al followed by Fe2 plus, and the last one is Br minus. That makes A option as the correct answer. So students, with that, we have completed all the 30 questions for the chemistry section of the paper. And don't forget to visit our website www.examsnet.com. Here you will find all of your entrance exam question papers along with the detailed PDF solutions. Also, you must download our app. The link is available in the description box for the same. So keep shining, keep rising high. That's all for this paper. Good luck. Bye.